Well, hello, everybody. I just wanted to do a quick video on finding the area underneath the normal curve. So if you go back into Folio, you'll see the probability PowerPoint lecture, and it says area under the normal curve. I'm going to kind of go off that and expand a little bit on how we can get a little bit more detailed in locating somebody that exists underneath that normal curve. And remember, this is really good for finding the percent of people that did better than you on a certain test or that had a greater score than you or a lower score than you, or if you're giving some sort of assessment to a bunch of individuals and you want to see how they're distributed, if a certain kid has a very high score or very low score, where do they compare to everybody else who took the exam? So finding the area under the normal curve is actually really important because it allows you to do a lot of really cool things in terms of what we call locating someone under that normal curve. And it may be that given your assessment, given the test, exam, whatever it is, that if someone's at, the ends and they're way different than everybody else, that you want to focus in on those individuals. So I'm going to go ahead and share my screen real quick so we can start to look at some of this stuff. So the first thing I wanted to mention again, this is the PowerPoint that you can find on Folio. I don't like the way that worked. Let's just stay here. This is the percent of normal distribution scores in each interval underneath the normal curve. So remember, the first step in being able to do anything with this is figuring out a z-score. So I have a specific score on a test. How does that compare to everybody else? Well, I have to develop my standard deviation score, the z-score. Remember, that's basically what it is. It's going to give you a score likely, very likely in between -3 and +3. If your z-score is positive, it means you're above the mean. If your z-score is negative, it means that you're below the mean. And then knowing that if, say, we're going to go back and look at that psychopathy scale example. So if you know that, most people aren't super, psychopathic, right? So a lot of people are right in the middle here. Again, 34% of cases are one standard deviation below the mean, and 34% of cases are in between the mean and one standard deviation above the mean. So, 68% of everyone who would take this exam scores in here. We want to be cognizant, right? If you're very low on psychopathy, maybe that's not a big deal. Sometimes it might be. It might mean that these individuals are like, very self-conscious, very anxious, and they don't have any sort of outgoing traits. So maybe, if someone falls way down here, you might want to be somewhat concerned. But generally, it's these really high psychopathy scores, right, that might indicate that something's going on with this individual. And so to calculate a z-score, remember, it's a pretty easy formula. You take somebody's score X, right? X is always going to be an individual person's score. So there's no line above it. It's not X bar, so it's not a mean. It's just an individual score. And then from that, we subtract the population mean or the sample mean. So you might see instead of mu here, X bar, so X minus X bar. Again, you're just taking that individual score X and subtracting the mean from that. Certainly, we have to also account for standard deviation. So you have sigma down here, signifying that you need to divide by the standard deviation. So first things first, if I want to see what percent of people did greater than an individual or less than an individual, I have to find out that one person's z-score, their standard deviation score. So let's go to our in-class example. We started doing this a little bit. And let's just say that we give a psychopathy test and we want to see, is there any individuals that are scoring very highly on this? They might need to be the focus of some sort of intervention. So on this test, the mean is 20. So we did, we selected a whole bunch of different people. Let's say we did 500 people. And so we got scores for all 500 people and got the average, the mathematical average or the mean, which is 20. So most people, if we kind of come up back over here, 0 standard deviation, that would be 20, right? Because you don't if you get a 20 on the test and the mean is 20, you don't have any standard deviation. You don't deviate at all from the mean. So your z-score would be 0. But right, 68% of cases are going to be between -1 and +1 standard deviations above or below the mean. We have a standard deviation of 6. So again, it's a pretty low standard deviation. While the mean is 20, most people, right, aren't going to deviate that much from that mean, only by an average of about 6 points on that scale. Let's say it goes from 0 to 100. So if someone scores 30 on that, what would be their z-score? And so we could do this real quickly. And so we'll go step by step here. I'm going to share this. And so anytime we want to get a z-score, right, that's going to equal the individual score on the test. So here we're saying that that is 30. We want to subtract the mean, which is 20, and divide by 6, which is the standard deviation. So again, the math here, not too hard, right? 30 minus 20, you're going to have 10 on top, 6 on the bottom. We're going to divide 10 by 6, and we're going to get 1.67. So this person's z-score is 1.67. Again, we did that by just taking their score here, 30, subtracting the mean, dividing by the standard deviation, 6. So their z-score, again, is positive, 1.67, so it's above the mean. But as of yet, we don't know exactly where they are underneath that normal curve. So I'm going to kind of clear this out a little bit here and draw that normal curve. Sorry, but it's never going to be perfect here. The x bar, the mean is going to be in the middle. We said that was 20. Now remember, there's one standard deviation above the mean and one standard deviation below the mean, right? 1 and -1. Well, we know the standard deviation is 6. So one standard deviation above the mean, we just add 6 to the mean. So one standard deviation above would be 26. We want to do one standard deviation below the mean. We subtract 6 from 20. And we get 14. So this means something really interesting, right? If I were to kind of ask you real quickly on the video, what percent of people are between a score of 14 and a score of 26? How would you do that? What percent of people who took the psychopathy test scored in between 14 and 26, in that range? And you should say, well, I know in here, that's 34% of people, right? This is another 34% of people. So if I add those two together, that's that 68%. Always remember, 68% of all people are between one standard deviation above and below the mean. Now let's go back to our case. This individual has higher than a 26, right? So they're falling above one standard deviation above the mean. So, they might be right in here. 1.67. So now I can ask myself a whole lot of different questions. And if we go back to the PowerPoint, I ask some of them on here. I say, what is the percentage of people who have a score between 20 and 30 on that scale? So in between the mean and that individual score. And there's a couple ways that we can do that. The first is that we need to look, so this is between the mean and z. So how many people are between the mean and that z-score that individual got? So if I come back here, I'm looking at the mean here and that individual score. So right in here, what percent of people fall in between the mean and that z-score? So it's that shaded spot right here. The way that we do this is we go back, and I have posted this on Folio. We need to look at our z-score sheet. So this is Appendix C if you have the book, but I have posted it here on Folio as well. We can start to calculate the shaded parts underneath a normal curve. So column B right here. So first we get our z-score. We already did that, 1.67. Now, knowing that, we can see what percent of cases are between the mean and the z-score that we calculated. And we can see what is the area beyond that z-score. In other words, what percent of cases scored higher on whatever it is that you're looking at in your sample. So you have A, the z-score, B, area between mean and z, C, this column here, area beyond z, those who have a higher score on whatever it is that you're looking at. So in our example, our z-score is 1.67. So I have to scroll down quite a bit here. And there it is, z-score of 1.67. Remember, this column, B, is the area between mean and z. So 45.25 cases are in between the mean of 20 and the z-score of 1.67, reflecting a score of 30. So if we go here, that shaded part here is this score here, 45.25. That's the percentage of cases. 45.25% of people fall within the mean and a score of 30. That shaded area right there. Now I ask a slightly different question here. I say, what percentage of people have a score higher than 30? So if we test somebody and they get a psychopathy score of 30, and we know that's 10 points above the mean, and we might say, okay, that's not too much. You know, someone scores a 20 or 30, it's a little bit higher, but the standard deviation isn't large, right? 68% of people, the first thing that we did, 68% of people are between 14 and 26. So actually, a score of 30 is pretty high, right? And so this reflects a score of 30, remember? So how many people now are in this spot above the mean? And we can actually do that quite easily. We can go back to here. 1.67, 4.75% of people scored. So fewer than 5% of people scored higher than 30 on the psychopathy test. So yeah, 4.75 is here. So that tells you something. This person is pretty high in psychopathy. Only, about 5% of people scored higher than that person did. So they're in the top 5%, right? On a psychopathy test, probably not great. On the SATs, the ACTs, if you're scoring better than or higher than 5% of the population, you're doing really good, right? And so it always goes back to the research question of what are you looking at? And so do you want to be in the top 5%? Or do you want to be in the bottom 5%? Sometimes it changes depending on what you're looking at. And then finally, the last question is, what percentage of people have a score lower than 30? Well, that's pretty easy to do. I think you can figure that one out. You would do 1 minus, so 1, 100%, minus that 4.75. If you look here, it's 95.25. So 95, just over 95% of everybody had a score lower than that individual. Makes sense. 4.75 had a score higher than that individual. 95.25 had a score lower than that individual. This will always add up to 100, right? Because underneath the normal curve, 100% of all scores. So 95.25 from here all the way down here, lower score, 95.25%. So I know this kind of looks a little bit messy at this point, but go back and rewatch this video, take it step by step, and see how we can start to answer all sorts of other questions related to, what percent of people would do better or worse, or in between the mean and that individual score. The normal curve, remember, is symmetrical. So if you had a negative z-score, you could still use everything that you see right here, because it's a mirror image, right? So we can just use the absolute value for a z-score. You don't have to worry about adjusting anything for a negative z-score because it's absolutely symmetrical in terms of the normal curve. So all of these percentages, all of these numbers stay exactly the same, whether it's a negative z or a positive z. And so again, I'm going to stop sharing my screen for a minute. I really hope that's kind of useful in finding the area underneath the normal curve and locating an individual score. Again, you might have to watch this video a couple times until it gets cemented in your head. But as we move on and we start doing t-tests and ANOVA, kind of understanding a little bit about the normal curve and what it means, I think is going to be really important. So I wanted to make sure that you had this at your fingertips. And as always, if you have questions, just let me know.